Pydantic AI's primary mechanism for extending agent behavior is the capability, a composable unit that bundles tools, instructions, and lifecycle hooks into a single parameter passed at agent construction. The code below demonstrates an agent instantiated with 4 built-in capabilities, each providing a distinct interaction channel: web search, web content fetching, image generation, and an MCP server connection. The setup registers an anthropic model alongside web search and web fetch as auto-detecting fallbacks, image generation with a specified fallback model, and an MCP server via URL, showing how provider-adaptive capabilities let a single agent configuration work across different LLM backends without code changes.
From Pydantic AI Import Agent. From Pydantic AI, capabilities import MCP, image generation, web fetch, web search. Agent equals agent. Anthropic, Claude Sonnet 4.6. Capabilities equals hash auto-detects DuckDuckGo as local fallback. Web search. Hash auto-detects Markdownify-based fetch as local fallback. Web fetch. Hash built-in when the model supports it, falls back to a sub-agent. Hash running the specified LLM with image generation support. Image generation fallback model equals openai-responses, GPT-5, 4. Hash auto-detects transport from URL. MC Perl equals https://mcp. Example, com/API.
This agent wires 4 provider-adaptive capabilities into a single agent: web search, web fetch, image generation, and MCP, each one auto-detecting whether the model supports the tool natively or falling back to a local implementation. Web search uses DuckDuckGo locally, web fetch uses Markdownify, image generation falls back to a sub-agent running GPT-5, 4, and MCP connects to the specified URL. The model is Claude Sonnet 4.6, so for the non-native tools, the fallback paths activate automatically. The pattern here is capabilities as the extension point for reusable behavior, letting you compose toolsets, hooks, and instructions into a single list without threading arguments through the agent constructor. Image generation explicitly sets a fallback model for the sub-agent case, which is a practical production consideration. If the primary model can't generate images, you need a secondary provider lined up. MCP takes a URL and auto-detects transport, so the same code works across different MCP server setups. Let's break it down.
From Pydantic AI Import Agent. From Pydantic AI, capabilities import MCP, image generation, web fetch, web search.
Imports agent from Pydantic AI and 4 capability classes: MCP, image generation, web fetch, and web search, for later use in agent construction.
Agent equals agent. Anthropic, Claude Sonnet 4.6.
Creates an agent bound to the Anthropic Claude Sonnet 4.6 model provider. Only the first parameter is visible here. The model identifier and likely additional configuration follow.
Hash auto-detects Markdownify-based fetch as local fallback. Web fetch.
Creates a web fetch instance with no arguments, registering it as a web fetching capability.
Hash built-in when the model supports it, falls back to a sub-agent. Hash running the specified LLM with image generation support. Image generation fallback model equals openai-responses, GPT-5, 4.
Configures image generation to fall back to a sub-agent running GPT via the openai-responses provider when the model lacks native image generation support.
MC Perl equals https://mcp. Example, com/API.
Instantiates an MCP server connection capability pointing to https://mcp. Example, com/API added as an element in a list of capabilities. Capabilities are the extension point. You bundle tools, instructions, and hooks into a single list and hand it to the agent constructor. Here, web search, web fetch, image generation, and MCP each auto-detect whether Claude Sonnet 4.6 natively supports them, falling back to DuckDuckGo, Markdownify, a GPT-5, for subagent, or a direct URL connection, respectively. That provider adaptive fallback chain is the connective tissue. It means one agent configuration survives across different LLM backends without touching the code. Image generation is the only one that explicitly names a fallback model because you need a secondary provider lined up when the primary model can't generate images. Everything else just works automatically from the URL or the empty constructor call.
Image generation forgets its fallback model and spawns a subagent from nowhere it has never seen before.